All right, these are the answers to number 2 from the quiz 7173 review. We're given a region that's in the first quadrant, defined by the square root of x minus 3, and this line negative 1/2 x plus 5.5. So I went ahead and went to y equal, I plugged those in. I went from 0 to 11 and 0 to 7 just from kind of guess and check, and it gave me this graph right here. So we're talking about this region right in here. And the first question we're asked to find is what's the area? So if I want the area of this, and if I'm going to do it up and down, then what I need to do is take the area in terms of x from here to the intersection point of just the square root function. Just do that. Then add to that from the intersection point to here of the line. And there's nothing wrong with that. You're welcome to split it into 2 different integrals at that intersection point. But what I'm going to do is, since I know what the other questions are going to ask me to do anyway, is I'm going to flip them and I'm going to write them in terms of y. And I'm just going to do top or right function minus a left function and do that from bottom to top. So first off, let's find out where they intersect. If I hit enter, enter, enter on the intersect, I get at 7, 2. So let's draw a quick little picture of this. All right, we've got this graph going like this, and then this graph coming in like that, and we're intersecting at 7, 2. All right, and this function is the line, the y equal negative 1/2 x plus 5.5. Now, if I were to get that in terms of where x is by itself, I would subtract 5.5, and then I would multiply by negative 2. And if you do that, you end up with x equal to negative 2y plus 11. All right. And what that's going to tell you is how long this is in terms of wherever y value you're at. So when y is 0, this length is going to be 11. When y is 1, this length is going to be 9. When y is 2, this length will be 7. That's what we see right there. Okay, so that's this graph. The other one, the y equals square root of x minus 3, if I get that with x by itself, I square, add 3, I end up with x equal y squared plus 3. So now if I put 0 in for y, I get 3. That's this distance. If I put 1 in, I get 4. That's this distance. If I put 2 in, I get 7. That's this distance. And so what that means for my area then is I can take the longer of the two, which is the negative 2y plus 11. That's my top function, minus the bottom function, y squared plus 3. That's top minus bottom, times dy. That's the height. And we can integrate this in terms of y, so we're going to be going from bottom to top, which is 0 to 2. All right? So on the calculator, all right, I'm going to go math 9, 0 to 2. And we're going to go negative 2x plus 11 minus x squared plus 3 dx, enter. I get 9 1/3. And if you had gone, like I said, if you had gone from 3 to 7 under the square root and then 7 to 11 under the thing and worked and added those two together, you should get the exact same answer. But I knew what we were asking next, which is what's the volume of this if we rotate it around the line x equal negative 2? In other words, if we take this same region here and we spin it around this line, well, now we have a big radius that's going to be this outer function, the negative 2y plus 11 plus 2 more. So it's negative 2y plus 11, the function, plus 2 more. That would be the big radius. And obviously I could have made that plus 13, but wanted to make sure you saw the separation there. And then the little radius that's going to be missing is going to be this part. That's the y squared plus 3 plus 2 more. So we're going to be subtracting y squared plus 3 plus 2 more squared. And we'll have pi times this from 0 to 2, and that will give us, with the little dy, that'll give us our volume there. So if I take the calculator, I can go pi math 9, 0 to 2. Of parentheses negative 2y plus 11 plus 2, so plus 13 squared, minus squared plus 3 plus 2, so plus 5 squared dx. Hit enter, and we get 507.681. air volume. Then C says, well, what if this is the base of a solid and you take cross sections perpendicular to the x-axis? So we're going to slice this perpendicular to the y-axis now. It's the shape of a square. So this is actually the easiest one that we could get. If you pull this, you slice it and look at it, you're just looking at a square. The length of the square would just be this length right here, which is the right function minus the left function. It's the negative 2y plus 11 minus y squared plus 3. That's the length of the square. So if you take that length and square it, that'll be the area of the square times dy will give you a little volume, and we're going to integrate that from 0 to 2. So on the calculator, I go math 9, 0 to 2 of negative 2x plus 11 minus x squared plus 3. All of that in parentheses squared dx. 54.4 is what we end up with on that. That's number 2.